This is the video notes that go with translating y equals mx plus b real life situations. Now, before we jump into our example, I just want to review our vocabulary, okay? So we've talked about in previous lessons that y equals mx plus b is called the slope-intercept form of a linear equation, okay? We've also discussed the idea that m, which is our slope, is also called the rate of change, and at times can be thought about as the unit rate, okay? B, that constant right here, is called the y-intercept a lot of times, but what it really means is that it's your initial value or your starting number. Now, what I mean by initial value, think about initials. If somebody says, what are your initials? You give them the first letter of your name. Initial value is the amount you start with, okay? Now, what's going to happen in these situations is we're going to be told a situation where you're going to start out with a given amount of something, but that amount is going to change on a regular basis, okay? It might be I start off with $30 in my savings account or my piggy bank, and I put $5 a week in my piggy bank. $30 is the initial amount because that's what you start with. $5 is the rate of change because every week you're putting in $5 more. That is a repeated occurrence that is predictable. It is always on a schedule, and it will happen more than once, okay? A lot of things in our life is like this. If you're on regular payment plans for your electrical bill, you pay the same amount every month. When I pay off my car loan, I'm paying the same amount every month, okay? It could be draining your swimming pool at the end of the summer. You start out with so much water in the pool, but every hour, so much water has drained out, okay? So we're going to be told an initial value, nice fancy way of saying the starting amount. And then we're going to be told how it's going to change over time, okay? So we've got two examples we're going to work together, and we're going to see how this goes, okay? Now, I just need to write this in right here, okay? Now, if I look at example 1, it says each test question is 5 points and you get 10 points for your name, okay? And y'all done this. You've been in classroom and teachers say, well, you know what? I'm going to make each question worth so much. That means you get even if you just do something, don't get anything right, you turn the paper back in, you're going to get those points. Teachers tend to say, hey, we're going to give you these points for putting your name on your paper and turning it in, okay? So this test right here is going to have an initial value of 10. Because if your teacher gives you your test paper and you turn it in, you've not even answered a single question, but you put your name on the paper and turn it in, you get 10 points. But then what's going to happen is that teacher is going to start checking your answers. And every time you get a correct answer, we're going to add 5 points to that. Okay, so you get one question right, 10 plus 5 is a grade of 15. Get 2 questions right, 10 plus 10 more points is 20. That 5 points is your rate of change because every single time you get a question right, you're going to get 5 points added to your grade. Okay, now once you've identified that initial value and your rate of change, all you're going to do is substitute those numbers into our slope-intercept form equation, which is right here, y equals mx plus b. Make sure we put our numbers in the correct spot. The coefficient for x is always your rate of change, so that's 5. The 10, the constant, is always your starting amount, and that would be my 10. Okay. Now, once we've got to here, we can graph this easily. Okay, so I'm going to go right here on my graph, and we know how to graph this from a previous lesson. We know we start on the y-axis at our b, which is 10. So we're going to start right here. Now, our rate of change up here is 5, which would be 5 over 1. And we know that's the same thing as rise over run. So that means I'm going to go up 5 and to the right 1. Well, look right here. If I go up 5, I'm actually just going up to the next line because my graph is scaled by 5s. So starting at 10, go up 5 to 15 and go over 1. Now notice I just went over 1 here because the x-axis is just numbered by 1s right here. Now let's do that again. Up 5 more from 15 to 20 and over 1. Now we know we got to have a minimum of 3 points, which we have. Now we're going to graph our line, but we're going to think about minimums and maximums and arrows and endpoints. I know that this is as low as I can go. I cannot cross back over here into quadrant 2 because then I would have a negative, think about that, you'd have a negative number of questions right. And there's no way you can get negative numbers of questions right. So I'm going to leave that as an endpoint. Now, when I connect these 3, I'm going to keep going all the way up my graph paper, kind of run off my graph paper right here, and I'm going to put an arrow because I can keep getting more questions right. Okay, I can keep answering questions and getting them right and adding 5 more points, 5 more points, 5 more points. This is not just the limit of where it stops. Okay, now another thing we might be asked to think about is, what would my table of values, what could it look like for this? Okay, well, we can just do it really quick. We got 3 points right here. The first point could be 0, 10. The second point could be 1 and 15. And my third point could be 3 and 20. Okay, now, here's your situation, your notes. If you need to pause it, make sure you've got everything copied down correctly. Please take time to do that, and then we'll move on to example 2. Now, example 2, again, is a completely different type situation, but very much a slope intercept real life deal. Okay, we've all done this, whether it be at Sheets. I have never done this at Sheets. I have done it at Panera for cups of coffee. I've done it when we've gone to Carowinds, and I buy that big old souvenir cup because I'm gonna get hot and thirsty riding all those roller coasters. But look at our situation right here. At Sheets, I bought a $6 refillable cup. Each refill is 50 cents. Now, we think about it. Our families have done that here and there. When you've gone, especially Carowinds used to be really big about it. You buy the cup and then you keep the cup and you just pay for refills. It's cheaper than keep throwing the cup away and go and buy a whole nother drink. Okay, now let's think about this. What is my initial value? Well, it's going to be the $6 because I got to buy the cup first, and I'm only going to buy the cup once. That's a clue when you're looking at a problem and identifying it. Your initial value, 1, is the first thing you're going to do or use, but it's only going to happen once. Now, the rate of change is something that reoccurs over and over and over and over. I know that's going to be the refill because that's what refill means to do, is keep filling it back up. So each refill is 50 cents. The word each also tells me that I probably got a unit rate right there. Okay, so I'm going to make that 50 cents. Now, because this is my rate of change, to help me out, I'm going to make that 1 over 2. Okay, I'm going to think about it also as 1 over 2 because it's a half. All right, so let's go right here. When we go to write our equation, well, we got a couple of options. I can use the 50 cents x plus 6, or I could use 1/2 x plus 6. It doesn't matter. I like the 1/2 only because I'm going to graph it. If I wasn't going to graph it, I probably wouldn't even deal with the 1/2. I just leave it as 50 cents. Okay, but we can do the 1/2 since we're going to graph. Okay, let's go down here and look at our graph. Take this down a little bit. Now, notice a couple things about my graph here. I am counting by ones, okay, on both axes. But look what happened right here. I didn't go 1, 2, 3. I jumped from 0 to 6, okay? That's what I call jump a bunch, okay? We jumped a bunch. If you jump a bunch of numbers in the beginning, just so you don't have to write it, because if I'd have wrote that, we wouldn't have started graphing until I was way up here. Okay, so I just kind of did save a little graph paper. I put this little zigzaggy line right there. That little zigzaggy line, I'm just going to throw it down here, is actually called a broken line. If you jump a bunch in a graph like that at the beginning to get to a bigger number to start graphing with, you put your zigzag line, and people say it's a broken line, but when you see that, you know somebody jumped a bunch, okay? It's not just counting by ones, okay? Just a little tidbit of information there. Now, let's go ahead and think about graphing. My y-intercept is 6, so I'm going to put a dot right here at point at 6. Now, my slope is 50 cents. So that means for every one refill, I'm going up 50 cents. Well, if I do that, let's see, go up 50 cents, that's halfway between 6 and 7 right here. Just like that, okay? But if I think about it as 1/2, from 6, I would go up 1 to 7, and then I would go over 2 right here to 2 on the x-axis. Well, look what happened. I thought about it differently. If I was going by 50 cents, that means I was going up 1/2 and over 1, up 1/2 and over 1. I get to the same spot I would get right here with the up 1 over 2, up 1 over 2. Now, I just like the up 1 over 2 part better because I'm on the grid lines. I'm doing whole numbers. I'm not having to think about decimals, but you could do it either way. Do the 50 cents and think about just going up halfway to 6, like 6.50, then to 7, then to 7.50, and to 8 for each refill. Or you could think about the 50 cents as being 1/2, which means you're just going to go up 1 whole over 2 wholes. So what that means is going up this way, for $1, you're going to get 2 refills. Well, that makes sense because each refill is 50 cents. Well, now I just kind of said that a couple different ways because, guys, people do look at this different ways, and no one way is always perfect, or the best way, I should say. They're all perfect, good ways to look at it, but some ways are just different. Not better, not worse, just different. Now, so we've got our graph. Notice again, 6 is going to be my minimum. Okay, I can't spend less than $6 because I got to at least spend $6 on a cup. Okay, I can't come back over here because then I would be in negative numbers of refills, and Lord knows how do you go to Sheets and get a negative number of refills? You can't. Okay, so 6 is the minimum. Now, can I keep that cup for a long time and keep buying refills? Absolutely. There's no limit to how many refills I can buy, so I can put an arrow at the top and say I can go on forever. Okay. Now, what if I wanted to create a table? Well, we've got a good graph right here. Let's just read off 3 points in our table. The first point we have right here would be 0, 6. At 1 refill, how much would it cost me? $6.50. If I have 2 refills, it's going to cost me $7. Okay, so I've got a good little table going there. Now, again, let's shrink this down. If you need to copy, please take a minute and let's get this copied down and put into our notes. And once you've got this into your interactive notebook, then you can go ahead and start your assignment.